So here's my implementation of the OOP Carpark. If we look at the main, let's just run it with its default config. We see cars come in. This is our actual Carpark. Let's stop for a second. Carpark will hold cars that have an ID of some sort. They'll come in, they'll stay for a bit, and then they'll leave. And if we watch it, we'll see cars come through. We might hit capacity, might not. Eventually cars will start filtering out because we've run out of cars. And there we go. So we have a couple of different configurations. So we had that one I just showed you, which comes in from this JSON, and you'll see here it's a list. So we can change a couple of things. So we can change this to barcode. And you'll see the actual IDs of the cars has changed to a UID. Operation will be exactly the same. Or we can change capacity of the car park. So if I say 50, actually, I'll go lower just because it's easier to show. And now we've got a tiny little car park that should fill up, and we'll see cars filtering in and out. We can have more than one car park. So here we've got car park A and B. Car park A has 3 entrances and 2 exits, whereas car park B just has the one of each. Car park A is a number plate car park B is a barcode car park. And we change that with config.json. So now we see both of them are running at the same time. Because car park B had an odd number of spaces, we'll see this last space here is just grayed out because it can't be used. If we focus on the actual car parks, we'll see they're running concurrently, which I'll show in a second, the actual code. But if we just go to the top, if we focus on this one, for example, we'll see it comes in at this point, stays around for 4 cycles of the logger, and then by this point it's left and it's being replaced by the next car in the queue. The config is loaded in by this config loader. So this is pretty basic, just a singleton here with the double locked, what's it called? Double checked locking. It won't matter because we only have a load in one of these, but and we'll see this. Use an object mapper that turns this JSON into these config objects, which get stored in a list. In our main, these get iterated through, and we create each of the things we need. If we show the actual bits before we go into this, first we've got our Carpark. So this inherits from or implements the interface for Carpark, which follows pretty closely with the UML you provided. And we've got basic constructor. These do what you'd expect them to. So the Carpark makes use of a hash map because all the operations will be O of 1. Carparks will come in, or cars will come in, vehicles, with an ID, which will act as the key. You can see here, if that ID already exists in the map, we throw an exception. If there's no space left, we throw an exception. Otherwise, we stick it in there, and then the vehicle gets set to admitted, and that will be relevant in a bit. But if we take a look at release, same thing, takes an ID, and if it's there, gets rid of it, otherwise does nothing. So this would be idempotent. If we take a look at vehicle, I guess I'll mention here, this is a concurrent hash map because things are going on concurrently. Just a thread safe data structure, so a lot of that head work you haven't had to deal with. So our vehicle is just an abstract class, very basic, just has the admitted and get ID. So it implements this identifiable, which is what the ID reader will look for. We'll pass in that and it'll make use of this get ID, which comes from this. Let's see. First. Yep. Oh, that was the other thing. We've got a custom exception here, which will be caught, which will inform the other parts of the application of what to do. So the things actually calling these methods, we've got entrances and exits. So these will run on threads. These are here for testing. So I can set this to false for testing, so the thread only runs one iteration, this, just so we don't have to wait in the tests, basically. So our entrances and exits hold all of these objects for our main flow of the application. So ID reader gets the ID from the vehicle. Sensor checks if there's anything in our gate queue. Barrier basically does nothing. And then the car park is where the vehicles will eventually go. So when we run the thread, it will continuously poll through here, and it will check this car park gate queue, which again we've used for O of 1 operations. So the queue, it only cares first in, first out. We've got a couple of things in here, on queue, DQ, as you'd expect. This try admit is the actual car park flow, I guess. So we know there's a car in the queue. So we're going to go in and we're going to see if there are no spaces left. Well, we just keep polling until a space frees up. Otherwise, we're going to get the ID. If that fails with a legal argument exception, we're just going to bin that vehicle, because we'll assume something's wrong and it shouldn't be in the car park. And that'll be relevant for the number plate and barcode implementations. Raise the barrier, get the vehicle, and then try and put it in the car park. If that's successful, we'll remove it from the queue and carry on. This was here for, well, I guess it's it makes sense for it to be there just to separate that out, but it was protected because I was overriding it in tests, which I eventually changed. So similar thing for the exit. All the same objects, similar flow. We do our polling, but instead of admitting cars, we're getting the ID from the queue, raising the barrier, and then we're trying to release the car from the car park. If anything goes wrong, we always want to DQ in this case, because either the car will have been released from the car park or the car shouldn't have been in the queue to begin with, and then we'll lower the barrier. So if we show the actual, I guess I'll entrances and exits extend this, which holds all of these things it expects to have, and just says that all gates should have an arrival, so a vehicle would arrive at the gate and should be runnable. If we go back and show all of these things. So we've got a car park, which we've seen the car park gate queue. Our barrier literally just is the barrier up or down, raise and lower. Doesn't actually have any real functionality. The sensor takes, that's annoying. Here we go. Sensor takes a gate queue and tells you, is there anything there? Our ID reader, if I show the, so this is the basic ID reader. So this will work for any vehicle, regardless of the format of the ID. Takes the gate queue, gets the actual item, and then returns the ID. Otherwise, it returns null. We've got a couple of different implementations of this ID reader. So this is the interface. We've got the number plate ID reader, which does the same thing, but verifies. If the verification fails, so we've got our regex here, we'll throw an illegal argument exception. And at that point, the entrance or the exit would bin these, effectively. We've also got a barcode ID reader, which does the same thing, but checks that it's a UID. If it's not a UID, it won't get through verification. We've got a vehicle, which we showed, very basic, and then our car actually has quite a lot of responsibility. So the car extends the vehicle, which implements identifiable and runnable. So each car will actually be run and will be responsible for its journey through the car park. So it will initially sleep, simulating it driving to the entrance. It will arrive at the entrance, which will put it on the gate queue. The entrance will run through its gate queue, so it won't necessarily be admitted straight away. It might never be admitted if there's too many cars in the queue. So we continue polling until the car is admitted. Once it is, we break through. We keep the car in the car park for some random amount of time, so that'll be between 1 and 5,000 milliseconds. And then once that is elapsed, we'll arrive at the exit, which, same as the entrance, will poll, and eventually the car will be released from the car park. Because this is a multi-threaded flow, we've got orchestrators. So we've got a car orchestrator that takes a list of cars. So the args constructor basically says this has to be instantiated with a list of cars, and it just runs all of the cars. Same with our Carpark orchestrator, that takes a list of entrances and exits in the constructor and runs all of those entrances and exits. For actual construction, because there's quite a lot going on, quite a lot of dependencies, I've used a lot of factories. So our most basic one is the reader factory, which takes our identifier option. We've got 3 options: any, number plate, and barcode. It will default to any, and then it will try to generate this actual ID reader. So if it's number plate, creates a number plate ID reader, barcode, and then this is our basic one without any verification. We've got our entrance and exit factories, which handle generating the entrance and exits. This takes a reader factory, so that this doesn't have to worry about how to actually generate the readers. So it loads in the ID reader, creates all the other things that it needs, and then returns the new entrance. Same thing is happening in the factory for the exits. We've actually got orchestrator factories as well. So we've got this one, which takes a entrance factory and an exit factory, the car park that they're actually operating on, and creates the number of entrances we want, the number of exits we want. So we just look at these, just iterating over the number, creating them with that factory and adding them to the list, then eventually creating this car park orchestrator, which will eventually run everything. Same thing for the cars. We've got, this takes a car park orchestrator because that will hold the relevant car park entrance and exit. I guess the car park doesn't matter, the entrance and exit. And we've got an identifier option because the car will be generated with that ID. So if we see here, case number plate generates a random number plate, which is just 2 characters, 2 numeric, space, and then 3 characters. So see here, just gets the Unicode for an uppercase character. This just gets a number between 0 and 9. This is UIDs, and then this, just for the sake of randomness, done UID and then just taken the first 5 characters. And the orchestrator factory just takes a car factory, generates the number of cars that we want, and then creates the car orchestrator with all of our desired cars. And we see that in action if we look at main. So first thing we do is load in all of our config, which we've already seen. We run through each config object. We create our Carpark, create a logger, which I'll show in a second, create our relevant orchestrators. So Carpark orchestrator first takes all of these and then generates the Carpark orchestrator. Same thing for the car orchestrator, which actually takes what was returned from this and creates all the cars. Stick them all in threads, run them, start them, add them, start them, and then actually start the flow of the program. If I show again, we can see things coming in, things leaving, everything's going concurrently. So between, there's no guarantee that we see things get replaced there. There might have been 2 cars in that space. That 1 second could, depending on the actual wait times of some of these things, we can see this one's empty now, so that one will never fill back up. If I show you the verification, if we go back to default.json and we change this to number plate, we should see that our Carpark never actually gets any cars in it because they won't pass the verification stage. So you can see every time it pulls over the entrance, it's deciding that the car is not in the correct format and it's just binning them. They never get to the car park. Trying to think. Number of cars. I don't know if it's worth showing these. I could show that things happen a lot faster if we have a lot more entrances and exits. If I were to do, 100 cars. Obviously, this is dependent on the car arrival and exit interval. Oops. There we go. Immediately full. I was convinced it was broken then because that one wasn't leaving. But yeah, we can see that the car park stays for some random amount of time and then eventually will hit the exit and actually be released from the car park. yeah, I think that's everything relevant. I'll show you test coverage. Pretty good. So the only things that aren't tested are main, because I didn't really feel like doing integration tests, and the logger, which I guess I will actually show. So it just takes a Carpark. This is the only one with an operation above O of 1 on a data structure. We do an O of n. We just get all of the vehicles, the hash map from the Carpark. And we start to build a string. So for each entry in the map, we just start building up these Carpark spaces. And we'll see that if there's no, if there's more capacity than there are cars, we'll fill in the spaces here. If the capacity is an odd number, we just fill in a space with forward slashes. This stuff's cool, but not worth showing. There's no real business logic here. If I run over some of the more difficult tests quickly, the car tests were relatively annoying. I would have rather done this event-driven if I were to go back and do it again. I'm not super keen on the car actually having knowledge of the entrance and exit existing, or the vehicle having an admitted status. So I think if we were to do an event flow where an event gets triggered where the car has arrived at the entrance, maybe then the entrance sends an event to say, hey, the car's in the car park. Something in the background could wait a while and then send another one to say, hey, send the car to the exit. But it's fine as it is. For now, we've got these sort of test variables, so we can say, hey, don't wait at all and don't care if it's admitted, basically, for that when the thread's run. Yeah, all of these will be in the write-up anyway. So, cool.